The Michaelis-Menten equation. The Michaelis-Menten equation describes the rate of enzymatic reactions. It relates the reaction rate to the concentration of substrate. V0 is the initial reaction rate or velocity measured in moles per unit time. S is equal to the substrate concentration. Vmax is the maximum reaction rate or velocity, and Km is the substrate concentration when the reaction rate or velocity is at half of Vmax. To get a better understanding of this equation, imagine an enzyme is like a parking lot and the cars are the substrate molecules. At first, there are only a few cars, so it's easy to find a spot, and the cars can park quickly and efficiently. This is an example of low substrate concentration, and the reaction rate is slow. As more cars arrive, more spots get filled, and the less spots there are readily available. The parking slows down because cars are starting to wait. This is an example of Km, or half of Vmax. Eventually, after all spots are taken, the lot gets full. This symbolizes Vmax, the maximum reaction rate or velocity. No matter how many more cars show up, parking can't go faster unless more spots are built, or in terms of enzymes, more enzymes are added. When there is a low substrate concentration, as seen in this diagram, there aren't many substrate molecules for the enzymes to bind to. Therefore, most enzymes are unoccupied, so the overall reaction rate is relatively slow. Now, as we move into this next diagram, there are more substrates. About half of the enzymes are working and the others are still free. This is the point where the reaction rate reaches half of its maximum speed, also known as half of Vmax, which is the middle ground. Within this final diagram, there are many more substrates and all the enzymes are occupied with substrates and fully saturated. The extra substrates that are not bound to an enzyme will not affect the reaction rate any further, as they have nothing to bind to create a product. This is when the reaction rate is at its peak, known as Vmax. So, as the amount of substrate increases, the reaction rate or velocity also increases, until all the enzymes are working at full capacity and the reaction reaches its maximum speed. This graph shows the relationship between substrate concentration and velocity when no competitors are present. As the substrate concentration increases, the reaction rate rises quickly and then levels off when the enzyme is saturated. This maximum rate when fully saturated is Vmax. The substrate concentration where the reaction rate is half of Vmax is called Km. Within these graphs, we see a comparison between when there is no competition and competitive inhibition. In competitive inhibition, the inhibitor competes with the substrate to bind to the enzyme's active site. Because of this, it takes a higher substrate concentration to reach the same reaction rate as before. This is why we see that Km increases, meaning more substrate is needed to reach half of Vmax. However, the Vmax stays the same because if you add enough substrate, it can outcompete the inhibitor and fully saturate the enzyme. Lastly, we can compare no competition and non-competitive inhibition. In non-competitive inhibition, the inhibitor binds to a different part of the enzyme, not the active site, called an allosteric site. This changes the enzyme so that it can't work properly, even if and when the substrate binds. Vmax decreases because the enzyme's overall ability to convert substrate to product is reduced. However, Km stays the same, as the inhibitor doesn't stop substrate from binding, it just slows down the overall reaction.